In this video, we're going to look at projectile motion problems using quadratics. So if you take a look at number 1, it says a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. This equation gives the height of the ball after t seconds. So if you were to draw a graph, this x value right here is actually going to stand for time, and it's written in seconds. That's what we're using. And this height is going to be in feet. So that's what it looks like. Now the question's asking, find the maximum height of the ball. Okay, we know once you have a parabola, this maximum height right here, that's your vertex. And we know how to solve the vertex. I'm going to use t instead of x, and I know my vertex is negative b over 2a to find that x value, right? So I'm going to plug it in, negative 90 over 2 times negative 16, and I get negative 90 over negative 32. If you type that in your calculator, you're going to get 2.81. You can round to the nearest hundredth. Okay, so now I know my x value in seconds is 2.81, but I need to know the height. I need to know what height it is. So all I'm going to do is I'm going to plug in my value of x. Uh-oh, don't know what happened there. 2.81 using the equation it gave me. So when I type that into my calculator, I'm going to get 126.56. So at 2.81 seconds, the ball is going to go 126.56 feet. So 126.56 feet. So you already know how to find that vertex, and that's exactly what the question's asking. All right, so now let's look, and it says, how many seconds will it take for the ball to reach the ground? Well, we want to know it's going to go up and when it comes to 0, because at 0 feet is when it touches the ground. So I'm going to plug in 0 for h, and now I can factor this quadratic. So remember, when you're factoring, your first step is always to take out the GCF. So I can take out a negative 2t, and that leaves me with 8t minus 45, right? Because you took the negative out to get that 45. So now, remember when we solve both factors. Negative 2t is still a factor. So t is going to be equal to 0. And then here I have 8t minus 45 equals 0. So when I solve for t, I'm going to get 45 divided by 8, and that's going to give me 5.625. So how many seconds is it going to take for the ball to reach the ground? It's going to take 5.63 seconds for the ball to reach the ground. Okay, so a lot of these, you know the terminology and the formulas. Now we're just putting them in the problem. Let's take a look at another one. Excuse me. All right, let's take a look at this apple problem. All right, so an apple is launched directly upward at 64 feet per second from an 80-foot tall platform. This is the equation where h is the height at the time t seconds. So again, if you drew a graph, t still is going to represent seconds, and h is height, and it's going to represent feet. I always like that visual so I know what I'm looking at. Now, it's asking for the maximum height. Remember, the maximum height of a parabola is going to be your vertex. So again, we're looking for the vertex, and we're looking for the height, which is that y value. So we use the formula, negative b over 2a, and I get negative 64 over 2 times negative 16. And I get negative 64 over 32, which is negative 2. So negative 2, negative b over 2. Oh, this is a negative 32. Sorry. A negative times a negative is a positive. I knew something was funny. Make sure you carry over those negatives. All right, so negative divided by negative is a positive 2. So now all you do, we found my x value. I just have to go back in and solve for y. So negative 16 times 2 squared plus 64 times 2 plus 80 So when you type this into your calculator, you are going to get 144. So at 2 seconds, the apple is going to reach a maximum height of 144 feet. Okay? Now, same thing, it's saying how many seconds will it take for the apple to reach the ground? Well, the ground is at 0 feet. So I'm going to plug in 0 for height, and I get negative 16t squared plus 64t plus 80. And remember, take out your GCF first. So you always take out your GCF, and in this case, it's going to be a negative 16. And then I have t squared minus 4t minus 5 equals 0. Okay? Now, you do set all factors equal to 0, but if you said negative 16 equals 0, that doesn't make sense. It's extraneous information, so we're going to throw that out. I still need to factor this guy, so two numbers that multiply together to give me negative 5 and add together to give me negative 4. That's going to be t minus 5 and t plus 1. And now I set these factors equal, so I get t equals 5 and t equals negative 1. Time, of course, cannot be negative, so we're going to cancel that out. So how many seconds will it take for the apple to reach the ground? It is going to take 5 seconds. All right, now let's take a look at number 3. All right. So now in science class, the students were asked to create a container to hold an egg. They would then drop the container to hold an egg. They would drop this container from a window that is 25 feet above the ground. If the equation of the container's pathway can be modeled by this, how long will it take the container to reach the ground? So we want to find the maximum height of the container. Okay, so the maximum height, again, it's going to be your vertex. So I get negative b over 2a, and I get, there is no b value. There's no b value, so 0 divided by anything is just going to be 0. So I get 0, and then when I plug in 0 here to find the height, I get 25. So when the time is 0, the height is 25 feet. So we know that the maximum height of the container is 25 feet. All right. And again, how many seconds will it take for the container to reach the ground? The container reaches the ground at 0 feet. So I'm going to type in 0 here. And I am going to factor. Now, I know that I'm going to use square roots on this one because there's no b value. So I'm going to subtract 25. And then I can make those both positive by dividing by negative, multiplying by negative. So I get 16t squared equals 25. And then to solve this, I divide both sides by 16. And I get t squared equals 25 over 16. I take the square root of both, and I get t equals 5/4. It does not make sense for t to be negative, so I'm going to throw out my negative 1, and then 5 over 4 is really 1.25 seconds. Because we're talking about time, you don't need a fraction. We're going to use the decimal. So the how long until the container reaches the ground? 1.25 seconds. So there it is for projectile motion.